In this chapter, we're going to talk about discrete probability distributions. So remember, discrete means numbers that can be counted. These are going to be probability distributions where most of the time the sample space values have whole numbers. In the next chapter, we'll then look at continuous probability distributions. So first we're going to talk about what it means to be a probability distribution and how we talk about these. So first we have a definition here. So we're going to define a random variable. So a random variable is a letter that takes on a set of possible different values determined by chance. So for example, if we were rolling a dice, we could get a 1, a 2, a 3, a 4, a 5. Or we could roll a dice a certain number of times and we could talk about how many times do you get a 5, something like that. So each value has to have a probability, and the value itself is represented by x. So then we're going to define a probability distribution. So a probability distribution is a table that gives the probability for each value. So it's just going to tell us what the possible values are and what the probability is. Now, like we have talked about, probabilities are always between 0 and 1. And if we have all of the whole sample space, all of the probabilities, the sum needs to add up to 1. So those are our two requirements. Each probability must be between 0 and 1, and the probability values need to add up to 1. So here's an example of a probability distribution. So x is going to be the number facing up when a fair die is rolled. So you roll the dice, and the possible values are 1, 2, 3, 4, 5, and 6. So here we list all of the possible values for x. And then on the right-hand side, we list the probabilities. So probability of rolling a 1 is 1/6. Probability of rolling a 2 is 1/6, and so on. And notice if we add them all up, if we add up all of the probabilities, so remember this sigma is the sign for a sum, so if we add up the probabilities, we'd have 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, which would give us 6/6 or 1. So this is a valid probability distribution. Here's another example for us. So it says, suppose you have 20 tables and 4 random adults are seated at each table. So, you're at a dinner party or at a wedding or something. You have 20 tables, 4 people are sitting at each table. You go around each table and you ask the question, what product is associated with the name Steinway? And then x is going to be the number of people at each table who know the answer. So 0 people could know the answer, 1 person at the table could know the answer, 2 people could know, 3 people, 4. And I should just point out that this exact question is not important here. You could do this for any question that you went around and asked the table, and just how many people knew the correct answer. Okay, so here are the results from the actual, if you actually did that. These would change based on the question and based on the situation, but just pretend you went around and asked them, and at 1 of the 20 tables, 0 people knew the answer. At 6 of the 20 tables, 1 person knew the answer. At 7 of the 20 tables, 2 people knew the answer, and so on. So x here is how many people at each table knew the answer. So P of x would be the probability that x people at the table knew the answer. So is this a probability distribution? So first we want to check all of these. Are these numbers all between 0 and 1? So they can't be negative and they can't be bigger than 1. So that's yes. Now the other thing we need to check is, do they add up to 1? So if we add these up, so 0.05 plus 0.30 plus 0.35 plus 0.2 plus 0.1, those add up to 1. So this would be a yes. So the reasons all p of x are between 0 and 1, and the sum of all the probability values is equal to 1. Now, we can actually find the mean and the standard deviation for a probability distribution. So to do the mean, you add up each x value times p of x, and we'll do an example of that. And the standard deviation, you take the square root of adding x squared times p of x, and then you subtract the mean squared. So you would have had to already find the mean. Now, that formula is a little complicated. The good news is that I will show you how to do it on your calculator, and it's just putting values into your calculator. So to find the mean of the probability above, so we're going to take the sum of x, p of x. So for each x value, we're going to take x times p of x, and we're going to add those all up. So for the first one, we'll take 0 times 0.05. Then we'll add that to 1 times 0.30. Then we'll add 2 times 0.35 plus 3 times 0.2 plus 4 times 0.1. We can do this in the calculator. So here we get 2. So our mean is 2. Now we'll see in a minute that the mean is also known as the expected number, expected value. And what this means is that kind of the average, on average, you would expect 2 people out of the 4 to know the correct answer. Okay, so we're going to go ahead and talk about how to find the mean and the standard deviation on the calculator. So when we want to find the mean and the standard deviation on the calculator, we're going to put the x value, so the left-hand column, into L1, and the p of x values into L2. So remember, to get there, you're going to hit Stat and then Edit. And then I'll show you when we actually get down to it. We're going to go to one variable stats, just like we did when we were finding the mean and everything else, but behind it we're going to put L1, comma L2. So let's work through this example. So it says there are 5 children in one family. Let the random variable x be the number of girls in the family. So you could have 0 girls, 1 girl, 2 girls, 3 girls, 4 girls, or 5 girls. So p of x is the probability of having that many girls. So the size of the sample space. So we can actually use our fundamental rule of counting that we learned in chapter 4. So the number of ways to have either boys or girls. So if we're having 5 children, I'm going to come down here. 1, 2, 3, 4, 5. Well, there's 2 ways to have the first child. Either they could be a boy or a girl. 2 ways for the second, 2 ways for the third, fourth, and fifth. So we're talking 2 to the 5th power, which is 32. So there are 32 different possible ways that we could have boys and girls. Now, there's different ways that you could find the probabilities. One way would be to make a tree. Remember, so you could do boy, girl, and then off of that put boy, girl, boy, girl, and do that for five times. The other way you could think about it is when we did permutations with repeats back in chapter 4. So, does this table fit the definition of a probability distribution? So, yes, and we'll figure out why. So, each probability is between 0 and 1. And if we checked it, if we added up those probability values, they would add up to 1. So now we want to find the mean, and here's how we're going to do it on the calculator. So we're going to go to Stat and Edit, and if you have anything in L1 and L2, clear it out. So we're going to put the x values into L1, and then we're going to put the p of x values into L2. So L1, we have 0, 1, 2, 3, 4, oops, I have 3 and 4 on the same row, 3, 4, 5. And then the p of x, you can either put the decimal or you can put the fraction, it doesn't matter. So I'm going to type in the fractions, it'll actually change it to the decimal for me. Okay, so we have all of those values in. So once you have them all in, make sure you've hit enter after the last number. You can just go back to the home screen. Okay, so that was just second mode. Now, to find the mean and the standard deviation, we're going to go to Stat and over to Calc and choose one variable, Stats. Now, if it comes up with this menu, you'll put list for L1 and then frequency you're going to put L2, which these L's you can see are above the numbers. So you can hit second, L2. If you don't see this menu, you're going to, after the one variable stats, you're going to type in L1, comma, L2. So you'll hit calculate. You'll see something like this. So the mean where it has X bar. So here it'll be 2.5. And for the standard deviation, it's where it says sigma X. So here we'd have 1.1. So that's how we find a mean and a standard deviation of a discrete probability distribution.